Next up, we have Yung-Hsiang Lu from Purdue University. I mentioned this morning, Yung-Hsiang is overseeing the Low-Power Image Recognition Challenge. I think this is very relevant to what many of the companies in the Embedded Vision Alliance are doing and what many of the end product companies developing vision products are doing, in the sense that vision applications tend to be very computationally demanding. But in order to get them widely deployed, we often have to find ways to implement them that are very energy efficient. And the Low Power Image Recognition Challenge is, I think, a very helpful way to encourage people in that direction and illuminate some of the progress in that direction. So Yung-Hsiang, welcome.
Okay, thank you very much. Thank you for giving me the opportunity to speak here. I'm talking about the low-power image recognition competition. The first competition was held earlier this year. It's part of IEEE Rebooting Computing Initiative. Why do we want to do this? I think even though I have been here for only half a day, I have heard a lot of people talk about mobile, UAV, and so on. And image processing obviously is very computation intense and requires a lot of energy to compute. So what we want to do is to understand the state of the art and see where we stand and how we can improve. We want to, I think I don't have to explain to you, vision is a very important technology. It's an enabling technology. With the vision technology, we can do a lot of things. But at the same time, energy is really a constraint. If you do a lot of computation, then you'll drain your battery pretty fast. And why do we want to do a competition or some kind of benchmarking? Actually, earlier we heard about the autonomous vehicle. One important milestone was the DARPA Grand Challenge at that time. Before the challenge, actually the first time the challenge was launched, no team actually passed. Then the second year, I believe 3 teams actually reached the finish line. So it was a very important milestone. And also the X Prize for spacecraft. Competition attract public attention, and image recognition competition started in 2010. What we have done is to add the energy component. Your score is the accuracy of a recognition divided by energy. As simple as that. So this is an example of an input. Suppose you get this image, then your program needs to tell us what is inside. And then your program also needs to tell us where it is. So you need to show what we call a bounding box. In this case, we have a person, we have a car, motorcycle, and so on. So you have to say, there is a person, there is a car, and where it is. And how do we calculate that? This is a little bit simplified, but I think that gives you an idea how we calculate the score. Suppose the correct answer is marked by the solid line. That's how we annotate the images as the correct answer. And suppose your program tells us the bounding box is the dashed line, then your score is calculated by the intersection of the 2 bounding boxes divided by the union of the bounding box. If it's above 0.5, then we consider that's a valid recognition. So that's the first part. You have to find where it is. Then the second part is you have to find what it is. We use 200 different categories, including, these are just a few examples: airplane, banana, orange, laptop, and so on. So these are the examples. We are using the database from ImageNet, and I will say a few words about this competition. This is an image recognition competition without considering energy. You can see some examples here. You can see this example is tiger, and then this example is banana, and then this example is train. You can see there are different types of trains. They may in different parts of the image. And if you go back to this image, a single image may actually have a different objects inside. So it's a pretty interesting challenge. This is the large-scale vision recognition competition. We are working with the organizer of this competition. The competition started in 2010, and you can see there's been a significant growth of this competition. In 2014, there were actually 123 entries. And it has a lot of news coverage. What's interesting is what happened this year, the competition is so important. A company, it's a very big company, I don't want to name it, actually decided to cheat, and they were caught. If you think about it, it's something you are willing to spend effort to cheat, means you take it very, very seriously, right? So it indicate how important this competition is. And in the competition I'm talking about right now is to take that image competition and add energy component to it. We divide the accuracy by energy. Also, the image competition without energy has no time limit, has no energy limit. What we do has a time limit. We limit each team have 10 minutes. It's a live competition. You bring your machine to the competition. And we also have, obviously, we measure energy. So in the next few slides, I will give you an update of what's happening this year. It's a snapshot of state-of-the-art. This is the first time we organized this. It was a one-day workshop in San Francisco together with the Design Automation Conference. I think many people here are from the EDA industry, so you probably know that conference pretty well. We got 34 registrations from 10 countries in 13 different organizations and 4 different countries. Finally, there were totally 8 out of 10 teams were able to present their solutions. 2 of the teams, they couldn't make it work on the spot. And these are the sponsors, including the different organizations, IEEE and NVIDIA. I think NVIDIA is a member of this alliance. Where is the NVIDIA representative? Okay, thank you. Thank you for being a sponsor. Actually, the whole thing started when David Kirk and I were in a meeting, and we started this idea almost 3 years ago. So these are the participants. And this gives you a rough idea of the machines they brought in. This year being the first time, most people use commodity hardware, laptop, tablet, and so on. And some people bring their desktops. Being the first time, we had no restriction about the machine, as long as we have a way to measure your power. And in the website, our website, we explain how we measure power. We give you a very detailed specification explaining. And one group actually brought the customer FPGA. It's in the lower part, but that FPGA wasn't able to work, so we didn't see how good it is in this competition. The winners, the champion was the Tsinghua University and the Huawei. The machine they use is NVIDIA Jetson, so thank you for NVIDIA for providing the hardware to them. The second prize is Chinese Academy of Science and the Institute of Automation. And also, they are also sponsored by Huawei. So they actually win, Huawei actually win the first 3 prizes. Because each team, if you have multiple registrations, you can present multiple solutions. So some of the teams, they have multiple registrations, they provide multiple solutions. And then Tsinghua Huawei also win the highest accuracy with low energy. The criteria of that prize is available on the website. And then we also give 2 special prizes to Carnegie Mellon and Rice University. So these are example pictures. There will be a special session in ICCAD in November. The 2 winning teams, the top 2 winning teams will present their solution. One of the team actually told me they are thinking about applying for a patent, so they want a pretty limited public disclosure at this moment, but they promise they will tell you everything in November. So if your schedule allows, please attend ICCAD on November 2nd. It's a special session. And unlike, I think, Free and Cassie earlier, they said, don't tell anybody what I'm telling you here. For my presentation, please tell everybody. If you want to tweet, you want to put on Facebook, please. Okay, the next few slides, I will give you the result from this year's competition. This is the accuracy. It's called the mean average precision. The more precise definition, I will be happy to give you later. But this is a rough estimate about how good it is. To put these numbers into context, we compare this with the competition without energy as a limitation, without time as a limitation. The accuracy is approximately 30% of state-of-the-art, considering they have energy and time constraint. So 30% of state-of-the-art actually is pretty good. I hope the teams next year will make it even better. And this shows the energy. Each team got 10 minutes. So you divide this watt-hour by 10 minutes. Each team, most of them consume a couple watts. That's most of them, except that there were 2 data points here. They brought their desktops, and so their energy is way higher. Mostly it's a couple watts. As I mentioned, nobody used special hardware this time. They are either embedded boards or laptop, desktop, or tablet. So I hope maybe next year we'll see some more innovative hardware. And it's the score divided by the accuracy divided by the energy. So for 2016, we'll make a few changes. 2015 is a live competition, but it's not elimination competition. It means you present your solution, we measure your score, measure your energy, and then we rank you. That's the 2015. And to 2016, we plan to have side-by-side competition. So that will bring a lot more excitement because you'll see real time which team is winning the other team.
Will there be betting?
Excuse me?
Will there be betting?
We can consider that. I'm not sure the conference allows that. But that's a very good idea.
I'm going with Tsinghua University myself.
Okay. So for 2016, we'll do with Design Automation Conference again because it's pretty successful this year. We think going with them, there's a very big crowd there. So I hope you can encourage your colleagues to participate. And we want to have more images. This year, we have 5,000 images. The team that did the most got about 1,000 images in 10 minutes. That's actually pretty impressive. And we are going to have some more limitation about the response time so that we will make the bar even higher. And next year, we also want to have a new idea. This year, the images are sent by network, so that there is no distortion per se. Next year, we want to have a new track, is the image will be captured by camera. So we'll show the images on computer screen, and you have to get that image from camera. So that will bring in all kinds of distortion, lighting, reflection to make it more challenging. That's our goal, to make it more realistic, like simulate human eyes. We'll see how that goes next year. For the long-term goal, we hope one day this will become an X Prize. X Prize means the winning team will get $10 million. And I hope you can contribute to that $10 million. We hope the X Prize, one day we can get there when you are allowed to use only ambient energy. No power socket, no battery. Obviously, that's pretty difficult. Real time, we want to have 1,000 categories and 1 million images in 10 minutes. I think that's probably hard enough and worse than X Prize. And each image may have multiple objects, as we already have, and so on. So why am I here? First, I want to publicize our event. I hope you can encourage your colleagues or your collaborator to participate. If your company can join, that's great. Or you can work with the university to participate. That would be wonderful. We are also looking for committee members. If you have great ideas, you want to share with us, you want to set the rules. This competition being only the first year, we still have a lot of room for improvement. So if you want to participate as a committee member, you are welcome. And we also want to have more data and annotational data. We want to have the correct answers. And that's currently it's still pretty labor intense. That's why you need students. Am I being recorded? Okay. We want to have new ideas and rules. And being a university, we are always looking for funding. We want, if you can contribute to travel grants for participants, equipment, and so on, prizes for the winners. Currently, the system is built by students as volunteers, and we hope we can give them some support. Actually, Jeff asked me to mention the participating teams. Some of the teams didn't win, so they don't want me to make it publicize their names. But I can tell you the names of the teams. They were from Brown University, Carnegie Mellon, National Taiwan, UCLA, Peking, Rice, Penn State, Virginia, Tsinghua, and the Chinese Academy of Science. These are the participating teams. So this is the final slide. If you are interested, go to the website, lpirc.net, You can see the rules, the source code of the referee system, the training data, and so on. And that's my email address. Thank you.
Thank you very much, Yung-Hsiang.